So sketching this graph then. So first of all, where's it cut the axis? Well, y-axis. You're on the y-axis if x is 0, and if x is 0, y is 0. So there's the point 0, 0. X-axis, if you're on the x-axis, y is 0. And if y is 0, x squared is 0, which means you've got the same point. I'll just put it down again, 0, 0. Maybe I should have said, which means x is 0. So that was easy. What about this now? Vertical asymptote. You'll get a vertical asymptote if you're ever dividing by 0, if the denominator is 0, in which case x is going to be 3. I'll just have a quick check of what that looks like then. So that means as x approaches 3 from behind, y is going to go off to, so at 3 it's 0, so move it slightly that way, it's negative, x squared is always positive, which means it's going to go to negative infinity. And if you approach 3 from the positive side, well, the top's always positive because it's a square, that will also be positive, it means it's going to tend to positive infinity. So if I want a little sketch of it, what happens at x equals 3? If I come from behind, I'm going to get pushed down. If I come from the front, I'm going to get pushed up. Non-vertical asymptote. Well, for this one, since I've not got a proper fraction, I'll have to do a division. The numerator's of a degree higher than the denominator, so I'll need to divide into it to see what I've got. I'll do my division over here. X minus 3 into x squared, so that'll be plus no x plus 0. So I'll need an x to make x squared, keeping it in the right column. That gives me x squared minus 3x. Subtracting, that'll be positive 3x. Now I'll need a plus 3 to make that balance the 3x. That's minus 9. Subtracting to see what's left over, 9. That means that expression could equally well be written as x plus 3 plus a remainder of 9 divided by the fraction plus 9 over x minus 3. And that now if I let x go to infinity, this part will disappear, which means as x tends to infinity, that was a bit nasty looking, y is going to tend to the x plus 3 plus this little part would be 0, so it'll just tend to x plus 3. So I've got y equals x plus 3 as my non-vertical asymptote. How does it approach it? I'll just do that bit down and I'll do it over here. So as x goes to negative infinity, what happens to this expression? Well, y would go to, I'm keeping that as x plus 3, and look, that's the bit I want to see how it approaches. This part here would be a negative, so it'll be minus an amount. As x approaches positive infinity, how does it approach this part here, this x plus 3? Well, that'll be a positive amount, so it's going to be slightly higher than it. So if I had my sloping asymptote, y equals x plus 3, what this says is, as I head towards the negative end, I'm going to be coming up from below, because it's the line minus a bit, and that bit's going to get smaller and smaller. If I head to the positive end of x, I'm above it, homing in closer and closer to it. Now the next part would be after that, what about the stationary points, turning points? Well, I can either differentiate that or differentiate that. There's not much difference between them just now, but when I'm going for my second derivative, you'll find this one easier. So I think I'll do this. When I'm looking for my stationary points, I'll work out dy by dx by differentiating this thing. So x would go to 1, the constant would disappear, and then that part would be, that's power negative 1. So it'll be 9 over, and then that'll go to power negative 2. I can find my stationary points by equating that to 0. I'll just make lazy and put equals 0. So if that equals 0, then I'm going to get rid of the fractions. So x minus 3 squared minus 9 equals 0. I could be lazy and just rub that out and put an equals there now, but I'll not. X minus 3 squared is 9. X minus 3 is plus or minus 3. So x is plus or minus 3 plus 3, which gives me two values. The minus 3 plus 3 gives me 0. The plus 3 gives me 6. So it's going to have those two turning points then. One at x equals 0 and one at 6. What are they? Well, when x is 0, y is 0. I've got that point already. Or when x is 6, maybe I should just put that down. X is 6. Y is going to be, I could use either formula. I'll just use this first one here. I've got 36 over 3, which is 12. So I've got 2 points. I've got 0, 0, and I've got 6, 12. Now it's just a case of what happens at either of those. Well, for that, I could get the next derivative, because that's quite easy in this particular form here. I'll put it here, not ideal. I've not employed my use of space very well here. Now differentiating, that means that disappears, and this term will just be, well, it's negative, power negative 2, so when you differentiate it, it'll get multiplied by negative 2, so it'll now be plus 18, and that power will now drop to a 3, as in a negative 3. And then, what's the value of that at each of those points? Well, when x is 0, the bottom's negative. It's an odd power, so it stays negative, which means that x equals 0. Where can I put that in? When x is 0, the second derivative is less than 0, and if it's less than 0, it's curving this way to give you a maximum. So I've got a maximum here. There's a maximum at 0, 0. When x equals 6, what's the derivative? Well, if it's 6, that'll make it positive 3, so it makes it positive overall. So the second derivative is greater than 0, which means it's increasing, so I've got a minimum there. Now I've got enough information to draw the graph. I'll just highlight all of that. First of all, what did I find? Well, they're both the same. I've got the intersection with the axis, only crosses once at the origin. I've got the vertical asymptote. That was the line at x equals 3. That's when it all goes wrong and it goes off to infinity. I've got a non-vertical asymptote, y equals x plus 3. Turning points, yes, there was a maximum at the origin and a minimum at 6, 12. I've got the approaches over here. Right, here's all the information. Wasn't actually an awful lot for all that working. These 2 turning points, and that was the only intersection with the axis. These 2 asymptotes. So it's just a case of put all that together. Right, there was a vertical asymptote, I'll just put in solid, at x equals 3. A non-vertical one at x plus 3. So it's going to be climbing up like this somehow. The y equals x plus 3. It crossed at the origin, and it had to be a maximum. And again, that's 3, again at 6. I don't know if I should mention the fact that that's crossing at 3 or not. It's not actually a point on the graph. 6, 12. Now where is 6, 12? Is it above or below? Test it against the equation of the line. At x equals 6, y is 9, so on the line the y coordinate's 9, which means that 6 must be above it then. So there's the point 6, 12. I've probably not got these lines going far enough to show what's happening. And then it's just a case of make it all match now. That's to be a maximum. What does it say for this? It should approach this line from the left by going down, and it should approach the non-vertical asymptote from below, and that all works out nicely, because if I just go through there and take a turn there, then start heading down, that'd be my part of the graph. This should be a minimum, and it should approach this one from the top and stay above for that one. So maybe I'll move that point slightly. So it's going to come down something like that and then turn off. Where that lowest point, it's easier to do it that way, is going to be 6, 12. And that's the only significant parts there were to the graph. So that's the solution.